Hello all, today we are discussing about the problem. We know that I1 and I2 are the input layers and H1 and H2 are the hidden layers and O1 and O2 are the output layers. And we are seeing different weights, that is W1, W2, etc. W8. W1 is given to H1 and W2 is given to H1 and W3 is given to H2 and weight 4 is given to H2, and this one is for the bias value. This bias B1 and B2 are same for both H1 and H2, and also H1 is given to weight 5.40, weight 5 is given to O1 and weight 6 is given to O1 and weight 7 is given to O2 and weight 8 is given to W8 is given to O1, and this B3 and B4 both these bias values are same for both O1 and O2. This 0.01 and 0.99 is actual target value. Our first step is forward propagation and second step is backward propagation and third step is putting all the values together and calculating the updated weights. Let's analyze the first step. In a single neuron, we are performing two calculations. First one is summation part, and then we are applying activation function. So first we need to perform in the summation part, that is from I1 finding the output of H2, that is I1 into corresponding weight W1 plus I2 into corresponding weight W2 and the bias part B1. Here H1 is getting input from I1, I2 and bias 1. So net input for H1 is it's equal to I1 into W1 plus I2 into W2 plus and then bias 1. So we get 0.05 into 0.15 plus 0.10 into 0.20 plus 0.35, that it's equal to 0.3775. Then summation part is done. Second we have to find activation function, that is 1 by 1 plus e power minus net H1. We know that net input for H1 is 0.3775, that is 1 by 1 plus e power minus 0.3775. It's equal to 0.593269992. Then next also we have likewise we have to find output of the H2. In this, here H2 is getting input from I1, I2 and bias 2. So I1 into corresponding weight W3 plus I2 into corresponding weight W4 plus bias 2, that is equal to 0.3925. So summation part is over. Next we have to find activation function, that is 1 by 1 plus e raised to minus net H2, that is equal to 1 by 1 plus e power minus 0.3925, which is equal to 0.5968884378. So we are calculate output H1 and H2. Then repeat this process for the output layer neurons using the output from the hidden layer neurons as input, that is calculating output 1 from H1, finding the output of O1, that is here O1 is getting input from H1 and H2 and their bias part, that is net output it's equal to output H1 into W5 plus output H2 into W6 plus bias 3. Output H1 we know output H1 value is 0.59326 9992 and their corresponding weight value is 0.40 plus and then output H2 we know that the value is 0.59688438 into corresponding weight is 0.45 plus bias value 0.60. So output so we get 1.105905967. Then output O1 is equal to, the equation is 1 by 1 plus e power minus net O1 is equal to 1 by 1 plus e power net O1 is 1.105905967, that is equal to 0.75136507. Likewise, we have to find output for O2. Here O2 is getting input from H1 and H2 and bias part. That is output H1 into their corresponding weight W7 plus output H2 into corresponding weight W8 plus B4, that is equal to 1.224921404. Then equation output for O2 is equal to 1 by 1 plus e power minus net O2 that is equal to 0.7729284665. So this output value and output O2 and output O1 values are not same as so this output values and target values are not same. So we have to calculate error values, that is error is equal to summation half into target minus output all square. So error O1 is equal to summation half into this target value is 0.01. We get output O1 is 0.75136507. So error O1 is equal to 0.2748111083 and error O2 is equal to summation half into target minus output all square. This target value is 0.99 minus and output O2 we get 0.7729284665 all square, that is equal to 0.23560025. So total error is equal to error O1 plus error O2. We get 0.29837110. Second step is back propagation. Next we are going to change the weight that affect the O1 and O2. We are change the weight value. Next we are changing the weight values W5 and W6 that affect the O1 and also bias part. So we have to find out new W5 and W6 and also the corresponding bias value. The equation of back propagation is delta O1. Delta O1 means rate of change of O1 with respect to error that is delta O1, and T1 means target value. So delta O1 is equal to T1 minus out O1 into out O1 into 1 minus out O1. That is we know that target value of output 1 is 0.01. So 0.01 minus, we know that the value of output O1 that is 0.01 minus 0.75136507 into 0. Out O1 value is 0.75136507 into 1 minus 0.75136507, that is equal to negative 0.13850. After calculating delta O1, next new weight. that is W5 plus is new, plus is mean as new, that is equal to W5. W5 is initial W5, initial weight of W5, that is 0.40, plus mu. This this symbol is learning rate. Learning rate, in this case we randomly choose between learning rate between the values 0 and 1. Here we assume learning rate as 0.5. So learning rate into delta over into out h1, that is 0.40 plus 0.5 into minus 0.13850 into 0.593269992 is equal to 0.359892. So we get a new weight 5, it's equal to 0.35962. Or likewise we have to calculate weight 6, new weight 6. Initial weight 6 is 0.45, so it's equal to 0.45 plus learning rate is 0.5 into and we know that delta O1 is negative 0.13850 into 0.5988444, it's equal to 0.40867. Also we have to find the value of new bias 3, that is new bias 3, it's equal to initial bias 3 plus learning rate into delta O1 into 1, that it's equal to 0.60 plus 0.5 into negative 0.13850 into 1, it's equal to 0.53075. Same way we have to apply delta O2 also. Thank you.